So welcome to one more episode of our podcast, Real AI Now. Today I'm very excited. We have Roland Becker as our guest. Roland is the founder and CEO of a company called Just Add AI. It's actually a group of companies. I think Roland will be able to tell us about that. And we've known each other for a few years, Roland. Roland has a great story. He started basically a few years ago, the company 4 or 5 years ago, and has grown it into an actual player in AI in Germany and in Europe. So welcome, Roland.
Thank you, Paulie. It's really a pleasure to be on your show and to talk to you. As it's always a pleasure, as you just said. So when basically we first met when I just started in the field of AI, that's actually more than 5 years ago. Time flies, right? But that was for sure great and very, very helpful for me as well. I mean, I think we first met at some IBM event, I think.
Yeah.
The main thing was we met in Las Vegas.
Yes,
the world of Western. But so as all of you know, what happens in Vegas stays in Vegas. So we cannot talk too much about that. But right. I think it set both of us up in a good way to build our companies.
Oh, exactly. So we actually started more or less at the same time in this business, let's say. And so you have quite an interesting story, I would say, for a tech founder, startup founder. It's not exactly the let's say conventional path. Could you talk a bit about that, about your story, how you started your career, what did you do, and how did you evolve into who you are today?
Well, how much time do you have?
So let's try. Let's try to keep it short.
I would try to just give a short summary. So in short, when I was at university, I was studying something completely different. But it was at the time of the new economy bubble. It was not burst yet. And my best friend was a software developer. So actually there we founded our first company. And that was quite successful. And then, I had a couple of years in the music industry, actually, helping to digitize the music industry, move from selling like physical products into selling digital products, like like download, stream, stuff like that.
Music mostly, right?
Yeah. Then I went into the mobile business. So building content delivery platforms and payment systems for mobile devices. I've been working with many European mobile network operators at that time. We built like really cool stuff, like mobile TV services where you could watch the Fußball Bundesliga live and stuff like that. And then I basically went into the startup world for a little while and built a social media startup together with some investors. Won some prizes there, but in the end, the social media world is a very difficult realm for business, really. So and then basically I moved on.
Can you say what social media platform that was? Are you able to?
The platform was called Flow Social, and the idea was that people who actually provide content that others like should somehow participate in the revenue, in the advertising revenue, which even today, I think it's mostly only the case on YouTube, which is part of why I think YouTube is still so successful. While on all the other platforms, the platform itself is very
makes the money.
Everybody provides the content for free, and they just make the money with it. And we thought we must change that, and we tried to change it. But we also learned during that time that if you try to incentivize people with money, that doesn't bring out the best in people.
Okay.
So, you know,
I've seen some attempts of doing that using a decentralized blockchain approach. So, but I don't know how mature these things are. But I've seen, I was at the blockchain trade show, and there were a couple of companies trying to kind of democratize the production of content and like the rewards for content and all that. So decentralizing that. A bit different from what YouTube does, which is pretty much centralized. They give the content providers a cut of the profit, but they keep most of it for themselves. And this was more decentralized, but I don't know how. I don't know how successful these attempts were. But that's very interesting.
The main problem is the business model. Advertising-based business models are difficult in the media world. It leads to all sorts of effects. So we are talking about AI, right? So AI algorithms which learn how to get maximum engagement from the users, because maximum engagement translates into maximum advertising revenue. And you get maximum engagement by playing humans with their emotions. And if they scream at each other, that's even more engagement. So, so you get all sorts of trouble with advertising-based social media business models. On the other hand, if you want to move on to business models, which are more like you have a subscription, you have to pay, then it's very, very hard to reach a critical mass of users to get the network effects that you need in order for these networks to be useful for users. So I think it's a very difficult space to be in. And also some other players at the time, there was a network called Sue, I think. None of that really broke through. I think the only other thing where people make some money is that, how's that called? Just OnlyFans or something like that. But that's more like into the red light world.
Shady.
Yes. So from there, I learned some interesting lessons there. And then basically I went on to consult some other startups and also startups who were active in the artificial intelligence realm. And that really ignited a spark in me. And then I actually, basically moved on to, as it always is, stuff seemed to happen by accident. Looking back, it looks like there's always some sort of purpose in it. But I actually met a guy, Stefan, who had a company in the IBM business area.
And that was V4IT. Right?
Yeah, so that was V4IT. So when we met, he said, well, what the business we're doing is kind of like legacy business, domino applications, Lotus Notes, whatever. All I'm seeing is IBM is investing everything in AI, and I thought maybe I should do the same. And I was thinking about launching an AI company. So we very quickly agreed on, okay, let's do this together, And I think, so we had that starting point at IBM. That's why we actually met.
Yeah.
Right, at that IBM workshop.
IBM Watson was very big back then.
Watson was quite famous at that time. That was 2016, I think. And and then we started to build the company and officially founded it in 2017. And in 2018, we hired the first employees, and the business was starting to move. And right now we have a little bit more than 50 employees. And we actually from the start, we had the idea to not only hire people and sell them as consultants, so be in the consultancy or body leasing business, but actually to try to scale via software. I think, that's, I think many people try it, but we seem to have found some sort of formula to it, because in the meantime, we have already three spin-offs, which successfully leverage AI-based products. That's the company Botario, which is in the realm of conversational AI. Then we have Scoutastic, which is AI-based sports scouting, mainly in professional soccer. And then we have Lector AI, which is a document management platform with AI. So these
Right.
these already exist as a part of our group. And we also just launched a quantum computing company called Qubit Flow. And we have
Yeah.
some more stuff in store where we think these could be successful companies probably next year.
Oh, very impressive. Starting from almost zero. So it looks like you've achieved something already. I guess you see a lot of work to do there, more
Yeah.
than the success, but this is already quite the achievement.
Yes, thank you. But I think it's important to always stay humble. I think both of us basically we were at the right time in the right place and did the right things. So timing is very, very important. That's also one of the lessons I learned in my other businesses that I built before. I forgot to mention that I also built the e-commerce business, which I sold later. That was also nice. But yeah, sometimes you got to be at the right place in the right time, do the right things, and then you can be successful if you work hard enough. But yeah, you always got to stay humble and say, yeah,
Yeah, definitely. It's like the timing, a bit of luck. Many people talk about you build your own luck. That's true, but
yeah,
you need
but
to.
yeah.
But you need to. You need to be there at the right time and the right place. So being lucky is a bit part of it. I agree. Sometimes things seem to fall on your lap, and you don't know why. And sometimes they do, and you're not ready for them, so you don't. So that also happens.
So, but you know what? So I don't know if you know Joscha Bach. He's
Joscha Bach.
Yeah, Joscha Bach.
Yeah. He's an influencer. So
a very, very interesting person to say that. So if you don't know Joscha Bach, check him out. Definitely. And he basically says what you perceive as luck is only second and third order effects of all the stuff that you do the whole time. So, and I also I thought about that for quite a while, and yeah, I think there's at least some truth also to that.
That's true. I mean,
because it's you can get lucky in terms of like winning the lottery, but first of all, if you want to win the lottery, you got to play.
You got to play the lottery,
right? So, and it's very seldom that you play only once in your life the lottery, and you win it. I don't know if that ever happened. So all the people who have won in the lottery have...
The probabilities are similar than playing your entire life. But let's not get into that.
Yeah.
Let's not get into that.
So I basically also believe in commitment, focus, and hard work.
I agree. So trying to bring us back to the topic. So we agreed that we're going to talk about one specific topic of AI today. Let's try to do that to keep the content engaging for our listeners and viewers. So one of the things that you haven't mentioned yet, I believe, is this out of the ventures that you have. One of them is around driving assistance. So using AI. So I understand that your team is working on, or it has already a product that helps tram, so the tram drivers to assist them basically while they're driving the tram. Can you talk a bit about that?
Sure. Yeah. So that's actually a very cool project. It was inspired by George Hotz, Comma.AI. So if you don't know what Comma.ai is, check it out. That's basically it used to be a smartphone-like device. Now it's a little bit bigger, smartphone-like device that you put onto your windshield from your car. And typically, you would do it in cars that don't have any meaningful or useful driving systems. And then you just plug it into the car, and then you have full level 2 autonomy. So it means on the highway, for example, the car can drive on its own, like fully alone. And we thought, well, if that's possible for a car, which has many degrees of freedom and has to navigate in complex situations, it must be a lot easier for trains, actually, who run on rails, right? And so we actually built a prototype and showed it to our local tram operator, Bremer Straßenbahn AG, BSAG. And yeah, basically try to convince them that could be a really good solution for all the existing trams which they already have on the road. Because of course, all the newer trams that are being ordered and delivered now, they have at least all sorts of sensors like cameras and radar, lidar, whatnot, and try to do some assistance things. But all the older trams,
don't have anything.
They don't have anything, like nothing at all. And you know what? These older trams are here to stay because they are so expensive. Their usage time,
they have like 40 years of
30
lifespan.
Yes. So these trams will already, they will be around for the next 15 years at least. So they have nothing,
If you think about, and that's in Bremen. If you think about like a city like Lisbon in Portugal, they have this retro trains, not even so, like the real classic 100-year-old, some of like 100-year-old trams that are around the city. Many of them are just touristic attractions, but they also need the driver. I mean, this is
and there are accidents all the time.
With
sometimes
cars,
horrible, but sometimes minor, but sometimes horrible accidents. So we thought, you know what would be probably really achievable is to build a device like with a camera that basically just warns the driver of like, hey, there's a pedestrian or something, or you're just driving too fast in this area. You're not allowed to drive this fast. Or all sorts of things where you can just warn the driver. It's not even about actually braking the tram. You can also do that, but then in order to achieve that, you need certification from all sorts of institutions, and it's a lot of work. But as long as you're not really changing anything with the actual tram, you can actually just build these systems, and that's what
you did.
Yeah, that's what we did, and it's very successful.
So tell me a bit more about that. So what kind of sensors do you have? Is it just cameras? It's one camera? Do you put cameras around the tram? How does that work?
So right now we have a triple front cam. So it's a stereo cam and a single 4K high definition cam. And
where do you install them?
We install them right at the windshield, right at the front, and so we are just looking forward right now. That basically, then of course we have a high performance compute unit with a GPU that is actually able to do like really fast real-time inference of these three cameras. And then we have a monitor also attached to that, which basically displays to the driver and also has a speaker actually. So you have sound alerts and visual alerts which tell the driver, something is wrong, or you're driving too fast, or all sorts of things. And but we also have additional sensors, which is also interesting. So we also have a high resolution GPS sensor to better understand where we are on the railway network. And we have a high resolution IMU. So, it's kind of like a gyro to understand what gyroscope. So for example, if there's a pedestrian on the railway, but from the gyro, we can already tell that the tram is already braking, it's already slowing down. No need to give an alarm, right? Because obviously the driver has already noticed. Same situation, but the gyro tells us, no, we are not braking, we are not slowing down at all. Maybe we are even accelerating. That's a reason to give an alarm. So, watch out, there's somebody,
Interesting. Okay.
So that was actually the initial idea. But you know what? We actually found out these additional sensors have a lot more value for the tram providers, because what we are now also doing together with another client in Germany who operates trams is to use these these sensors as smart sensors who basically check the infrastructure, the whole railway infrastructure. Like, are the rails themselves still in good conditions? Are there any whatever bugs in it? And if you drive through a tunnel, there always need to be these emergency lights, and they need to be working. You need to see them, you know. And then with that camera system, we can see all of that. We can check if at a tram station there should also be some lights in the night. We can check if these lights are all still working. If one of them is broke, and we can do all that automatically together with the assistance system. So that comes on top, basically.
Interesting. So it's basically a sort of a second agent that you have, or is it? Now I would like to do an exercise with you, if you agree.
Yeah.
Sure. That's an AI system, right? This is a combination of techniques, of AI techniques, and techniques that are not necessarily AI. And so, if you allow me, let's try to break this down, what the solution that you described, and kind of discuss how such a thing is built, right? Because I think it's an interesting topic. So sure. I can see that there is you have the cameras taking video continuous. There is a continuous video stream coming from the cameras into the system, and one thing that you do is detect objects, right? In the, like, people, for example, right? That's probably the most sensible thing you detect. This is our sensitive thing. So this is, and this is using computer vision techniques, right?
Right. That's correct. Yeah. So modern, like modern deep learning techniques, which are able to detect, okay, there's somebody riding a bike, a pedestrian, whatnot.
So this is a sort of one signal that you are analyzing while the train is driving. That's one. Then there is, you talked about GPS, so there's something around the position. You might analyze that too. You have the gyroscope that you use to measure what velocity, or do you do GPS for that?
The gyroscope measures if you're slowing down or speeding up, but in like all three dimensions, right?
Okay.
Not
so
on
you could also
backward, up, down, left, right, same thing.
So now you have, like, you're able to, let's say you have technology that allows you to see, it allows you to know where you are, it allows you to know how fast you are. You can detect objects, you know if they're moving or if they're not, and you can distinguish the car from a dog, from a person. Now there is a whole, I guess, right? I'm just guessing. There's a whole orchestration part to that, and I believe you could call that an agent in the AI space. And there's an agent that makes decisions based on what you see, right? And how does that work? Is that rule-based? You create rules for that, or how do you do that?
Yeah. So one thing actually that is very important that you kind of missed is actually detecting the rails on the road, on the street. That's like lane detection for cars. But here we need to detect where the rails are, where they are going also.
Okay.
And from that, we have to calculate the so-called Lichtraum. So the space that the tram needs in order to safely go through certain situations, right? Because the rails are obviously a little bit narrower than the actual tram, which is a little bit wider. So we need to calculate that. And then basically, yeah, so what
this is like, you do that using the video, right?
The video. We do that using the
So it's camera. Not just about object detection, is much more than that.
But actually, so that's actually one of the points that some of our competitors are really struggling with. I've just read a report from a large research project that has been running over the last couple of years, and one of the results was, yeah, but we need to work on our railway detection. So which is kind of, so we actually started with just doing that because we have a very smart guy in our team who actually won a prize for the best master thesis, where he was actually building a railway detector in his master thesis.
Okay.
Already quite nice. So so that's a very important basis as well. So and then the current version that we are using in production right now does exactly what you just described. So we detect all sorts of objects. We detect where's the railway. We know where the tram is going. We know how fast it's going, if it's slowing down or speeding up, stuff like that. We also have a clear understanding on a map where we are, what is coming up, if we are approaching a station or not, stuff. So we know a lot of stuff. And then basically right now, because it's not a system that actually is driving the tram, but it's just a system that is an assistant to the driver. So we just have a set of quite smart and intelligent heuristics, rules, basically.
Yeah.
Say, okay, if we come into this situation, we give an alert. But for example, if you're already slowing down, you don't need to be an alert, stuff like that. So that's what we are currently doing.
Yeah.
In production. What we are currently working on is something different, actually, because we are also in a larger project right now with a larger car manufacturing group and a research institution, where we work on predicting the intent of like pedestrians in this case mainly. Like, is this like we can detect there's a pedestrian like quite near to where the tram is going. What is the intent of this pedestrian? Is he going to cross? Is he going to stop? And I think that's like it's a very difficult thing. You cannot tell it from a picture. So you need a series, like you need video, you need a series, time series.
And you kind of need to understand if, I mean, they could be moving, but they might not be moving in a direction that they become an obstacle. So
that's a very
interesting,
a very interesting problem, but also one I think that is at least to the degree of stuff that we want to do there, it's also quite achievable. I'm also here again inspired by AI, who have recently shown in a couple of videos their system, because they have so much training data. They have trained an agent that doesn't have any rules at all. It's just end to end, taking the camera input from that one, or I think it's two cameras they have in the front, two cameras in the front, and that is directly translated into steering signals for the car without any additional model.
Just learning from driver behavior.
Yeah, like Tesla, for example, has this really sophisticated system where they recognize all these objects and then put them into a virtual 3D space and try to predict trajectories and this and that, and then kind of rule-based, make decisions. Oh my God, it works surprisingly well. So AI has actually shown they were able to drive a car through San Francisco, I think it was, like on its own, just using the camera, no rules, no nothing, end to end, camera input in and steering input out.
Well, with enough data, you can create a better model than
but you know what? When we started this, AI companies back in the days, you always said, yeah, you need so much data. I think that kind of has changed or is still changing, because there are so many of these really large scale models right now, which are open source, which you can use as a basis. And then you just fine tune,
Yeah, but you need data, right?
Data. You need
some data. So right now, I mean, I'm just a bit trying to dissect or demystify a bit the technology part.
Oh, it's magic! It's magic.
Now, so let's say that there's an agent, right? And the function of this agent is to help the driver.
Yes.
So it basically needs on a kind of a regular basis, check the environment around it, read what's happening in the sensors, what the sensors are telling them, or what the models are saying, also like the detection model, whatever the intent model of the rails or whatever it is, and then like on a regular basis make decisions based on those heuristics, I guess, right?
Mm-hmm.
That are right now kind of rule-based. They could become data-driven with machine learning models. So you could basically get rid of the rules and just learn the heuristics by the data, right? You'd have to record the driver's decisions then to do that, sort of.
Yeah.
But does it work like that? So do you have like an agent that every fraction of a second checks the environment and makes a decision and says, okay, is it time to warn or not? And then it checks on a regular basis, like a clock, or how does that work?
So it actually works continuously.
Okay.
And performance is really one of the key factors that you need to optimize here. Because what we want to do is on these mobile compute devices, basically, to not only make these predictions at a very high rate, but also at the same time record high definition data. So what we are doing is really like recording 4K resolution data, video, at the same time doing these predictions, like recognizing objects. I think right now we are for the inference, right? For the actual inference.
You need lots of compute power for that.
You need lots of compute
to do
power.
that very fast. Yeah.
So for I think right now, so we are for everything that we do simultaneously, we are still able to do this inference loop, like with a frame rate of 15 to 20 frames per second.
Okay.
So that's and I think you should not go below 10. Then it gets a little bit sketchy, maybe in a car for sure. In a tram, it's a little bit more relaxed, maybe. But yeah, if you gotta, our goal is to be like 15, 20 frames on the inference loop, while we are still doing all the high resolution sensor readings and recordings of data and displaying stuff to the screens and stuff like that. Okay. And yeah, that's actually, so there's many performance things here, because also all these systems that you have in all these mobile devices you have in the tram, you also need to manage them, right? So yeah, they actually record all this information. You need to download it somewhere, and the only chance where you can download it from these devices is at the service station, where each tram comes into the service station, but it's only there for like 10 or 15 minutes. So within 10 or 15 minutes, you have to be able to download like a terabyte of video data and stuff like that.
Do you have a connection to the internet in
the
train?
So right now, the trams themselves, they actually could have a connection, but they don't. There's also security concerns about that. Yeah. So right now, but we do have a management tool that is accessible, which is our main monitoring hub. So where we can actually see which tram has already been at the service station. And then when they are at the service station, they also upload all the logs from their last turn, all the recorded data and everything that happened is uploaded. And at the same time, we can also do software updates. So we can also do software updates over the air. And I think that's also very, very important. And all of, like, lots of cool stuff that
like a Tesla.
Yeah. But
connects to the Wi-Fi and then updates itself.
So there's so much cool stuff, so many cool things you can do with AI, but especially with AI, you need to be able to update it on the fly always, because you retrain stuff, you make it better. And so it's very important to have that.
So from what I hear, it looks like there's a lot of engineering there too. So how much would you say in that solution, that particular product, what's the percentage of more classic software engineering in hardware, and what's the percentage of data science and AI?
Yeah,
the amount of work that your team needs to put in.
So usually, right, in most projects, it's like 80% is engineering and 20% or what is AI. In this project, it's actually a little bit more AI.
Okay.
Because there are so many different tasks that you cannot get anywhere out of the box, like recognizing the rails, recognizing all these specific signs that the trams have, like, you know, they have different light signals and all sorts of weird things, you know,
Okay.
that you need to learn. So I think there is more like maybe 30 or 40% AI, but also like a very large chunk of proper software engineering. You know, there's lots of security concerns that need to be addressed. Yeah, like I said, the update mechanisms, you need to manage all these devices, check their health status and record all that data, manage that data basically when it's recorded. There's also lots of, by the way, so there's a lot of data protection stuff that you need to look at. So when we record,
when you're filming people, right?
You're filming people,
like people's faces,
you're not allowed to do that. So so what we do is I think we are the only company who do it that way, like in the most secure way, I think. So we already take out the faces and number plates of cars on the camera. So the faces of people and number plates of cars never reach the actual compute unit. Like we have an embedded chip in the camera.
Okay.
With an AI model inside of the camera who already does that. So it never reaches the hard disk. I think all other providers have systems where they say, yeah, we are also like
cleaning up ourselves. But...
Yeah. So, but there's always some time period where the data which is not anonymized is some sort of storage.
Okay, that's a good approach. So one of the questions I was going to ask you was about ethics, right? And what are the implications in terms of ethical implications and security? But you mentioned already, obviously, if this is not a closed loop, if there is some access to it, it could be hacked, right? And this is a risk, obviously. You talked about that. So what about the future? So you mentioned one thing was, okay, in the future, so you could add more sensors, you could do more things, you could use this to not only make everybody safer, but also to help maintaining the infrastructure. So I have two questions, actually. One is, what other value could this kind of solution have? Like, so beyond helping the driver, making everybody safer, and helping monitoring the infrastructure. And in terms of technology, how do you see this evolving? You mentioned one thing was basically moving from heuristics that are rule-based to data-driven heuristics, full machine learning based. What else do you see?
So there are basically so many possibilities that it's kind of hard to focus on some. Right now, so for example, one of the issues which are very hot right now is saving energy.
Yeah.
And we actually have offered now to some of our clients to kind of include a module in the system that helps the drivers to drive the tram with less energy consumption. Right. A little bit like gamification, so give them some rewards or points if they saved energy. I think there's a lot of potential there. That's for sure very interesting. And yeah, then, you know, there's a couple of, you know, you mentioned already a couple of things. I think technology-wise, we are going to move more into end-to-end systems. Then there are many possible applications that also have maybe ethical questions to them. For example, when we drive around, of course, we film everything. We can see there are cars parked where cars are not allowed to park.
Yeah,
and in this case, we could actually read the number plate and
could help the police
issue tickets, you know, parking tickets. I'm not sure if this is what we want to do. But
what if the, let's say, I'm just thinking out loud, what if, I don't know, the police is looking for a stolen car, right? Or
so
police is looking for the person.
Yeah.
So the person, for example, let's say there's a missing person. Right?
Yeah.
And you have the trams all over the city, right? So why should people look for them? Why not use the trains to look for people, right? To the face match. Okay, this is the person. I found the person here, and warn the police. Or maybe not just a missing person, maybe a person who is wanted by the authorities.
But so actually to discuss this, I think we don't have enough time today. I would love to come back and talk about this because it's very interesting from many aspects. In general, the surveillance of the streets and the public, I think, is increasing in every way, everywhere. All the cars have cameras. There are all more cameras in public places everywhere. And then the question is, who has access to the signals of these sensors? And then, of course, we both know what you can do with these. So this raises many possibilities, but also many valid concerns.
Ethical concerns.
Maybe one other thing that is in the end maybe a little bit less risky, but that we are also working on, that is basically to actually plug our system into the tram and have it actually at least like break the tram if you think there's some a situation that could be dangerous. And of course, we are also thinking towards driving the tram autonomously. At first, maybe at the actually home bases where there's no public traffic. I think that should be pretty achievable also in the near term. And I think on the midterm, it would also be very achievable to have self-driving trams in some, because trams always have the benefit. They have much less degrees of freedom as a car.
Yeah, they just.
So you always know where they would go. And if people know this is a self-driving tram, they kind of have got used to how it behaves. I think you can operate it quite safely. And that's where we're going. So plugging our system also into the tram, we are already working on that.
One thing that just crossed my mind is, I mean, these trams, they have this kind of, they are very, let's say, centralized way of transportation. So it's basically you have, I don't know, in the city of Bremen, I don't know how many are there, but there's a limited number of fairly large trams with lots of carriages. And so either catch the tram now or need to wait 20 minutes. So there is no, there's no units like there could be smaller and just take 5 or 10 people that you could kind of, that could be on a more, could come on a more like a quicker, more regular, shorter periods of time, like every 5 minutes or whatever. Do you think that this is a possibility that if these things become autonomous, which seems to be the future, that it could also change? I mean, you don't need a large tram anymore with so many carriages. Maybe you can also have a mix of larger, longer ones, shorter ones, some that take you from an alternative routes, because now you have the tram line, the red one, the blue one, and the green one, and that's it. That's the route. And they just go in circle or whatever. But why, right? If the system is self-organizing, why do you need that, right? This is a concept from that is 100 years old. It was designed for when the trams were driven by people, right? And they didn't have all this information. So does it make sense to create a public transportation system that takes people from A to B, a sort of a Uber, but with trams?
Yeah. So I think that for sure, this would make a lot of sense. It could be very efficient. You could also with AI predict at what time, in which places you need how many carriages and how many of these things.
Yeah, exactly.
But so as a vision, I think that's super cool, and you should work towards it. However, I think it will be a very long way because of the existing grown infrastructure and operating structures that we have. It'll be kind of hard to do that on that same infrastructure
Yeah.
And with infrastructure, I not necessarily mean the rails, but I mean like the operating entities, you know,
Yeah.
all
You
the
need
employees they
you
have.
maybe need a new competitor there.
Yeah, so you would probably need to open up these rails for competition
For other operators. Right?
for other operators, but then
That's
yeah,
hard.
this
Shared.
raises all sorts of other problems.
Yeah.
So yeah, maybe we
Anyway.
just need to think about then flying taxis rather, they who operate in different space, you know.
Like back to the future kind of thing. All right. Thank you, Roland. I think we could be speaking for hours about this stuff, and let's do it again in the near future,
For sure.
because it's a lot of fun talking to you about this. So thank you for joining us. Thank you for coming. Is there anything you'd like to add to what we spoke about until now?
Yeah, so I think, you know, I really think let's do this again. This time it was a little bit too short.
Yeah.
Unfortunately the bad is a little bit on my side, so I have a different appointment now that I have to go to fulfill. But yeah, I would love to come back. Thanks for having me, and then maybe we take some more time. You're also invited if you can make it to come to our podcast. ThinkReactor.
Yes.
Yeah, if people don't know it,
I will.
You can also check this one out. It's more of a long form format where we mostly like talk like 2 hours about stuff. So if you found this interesting, I will also invite Paulo there. I will come back here. It's been great. So, thanks for having me.
Thank you. Thank you for listening. Thank you for listening, for watching. Don't forget to give us a like down here, and to follow our YouTube channel. Thank you. See you soon.
Cheers.